All right, welcome to Force and Motion, Balanced and Unbalanced Forces, Velocity and Acceleration. All right, so first we're going to talk about motion. So what is motion, you might ask yourself? It is a change in the position of an object over time. So then how do you know if something is moved? You use a reference point. So for instance, a stationary, not moving object such as a tree or a street sign or a line on the road, that would be a reference point. So then if you have a reference point and you look to see if something moved in relation to that reference point. So what causes an object to move then? What causes that motion? It's a force. It's all motions due to forces acting on it. So then you're asking yourself, well, now I know a force causes the motion, but what is that force? It's a push or a pull. So as you see here, the hand applies a force to the car, which then creates motion to the right. So can more than one force act on an object at the same time? Well, if you look at this guy running here, you have the force of gravity pulling you down, which is numbered 1 there. Then you have your legs holding you up, which is number 2. And then you have your movement of running to the right, of number 3. So there can be more than one force acting at a time. So the total combination of all forces acting on an object is called net force. So if here, in our example, I have a force moving me to the right, so there's no force over here on this side resisting. Okay, so which way would the movement be? Yes, to the right. So you go by the arrows. Up and down, number 1 and number 2 are the same arrows. So I'm staying in the same place here, flat on the ground, but I am moving to the right in relation to where I started. Our favorite time of the day, recap time. What is motion? What is a force? And how does force cause motion? Please write that in your journal and be ready to share at any time. All right, so now balanced forces. So we just talked about a force, which is a push or a pull. So if you have a balanced force, it's when which the object, its net force is 0. So like if you look over at these little people standing in the sand over there, you have the gravity versus their legs. So the gravity is the 50 newtons pulling down versus their legs pushing back up at 50. So they're staying balanced. So are those people moving? Is there motion taking place? No, there's no motion taking place because I have 50 newtons of gravity and 50 newtons pushing against it. So it's keeping them perfectly still. Here I have Billy with the little goatee, the big old head, with Linda over here, who is just pulling away, but they're both pulling that rope with 25 newtons. So is motion occurring? I don't think so. Same amount of net force on each side, or net force would be 0, same amount of force on each side. That will be balanced force, no movement. Now on to unbalanced forces. So an unbalanced force is one in which the net force is greater than 0, meaning that my arrows don't add up to the same. So is there going to be motion? Well, let's look at our examples. I have 2 people skydiving over here. We have Raphael and Jocelyn over here just skydiving away. All right. 50 newtons pulling them down, right? That's pulling down with only 2 newtons of resistance. So is there motion? Do you move when you skydive? Most certainly do. Over here, I have purple team versus kind of a teal team. I don't know if that's really teal. But you have 25 newtons of purple, and I have 40 newtons over here on the teal side. So is there going to be motion? Let me think about it. Oh, yes, there will. Which way? Right, because look, see that arrow? See how that 40 newtons arrow is larger than the 25 newtons arrow? That's how I know too. The arrow will always be larger where there's more force. If they're over here with the skydiving, the 50 is much larger than the 2. So I can tell that it'll show me the direction. All right, the arrow shows me the direction and the amount of newtons by a larger arrow. So only an unbalanced force can cause the motion of the object to change. So the example we have over here on the right, your dog can cause you to move if he pulls with enough force. So if his force is greater than the force you're using to stay in place, then that's an unbalanced force. So if that dog is not well leash chained and it's just pulling, and you're going with it, then that's an unbalanced force. If you are holding it and no movement's taking place, you guessed it, that would be balanced. So you might be asking yourself one day, what would happen if an unbalanced force acted on an object that's already in motion? So something's already moving. What happens if an unbalanced force acts on that? Well, it will change the speed or direction of the object. So our example here is the little brother's riding his tricycle over here on the right. You run up behind him and give him a big push. So he's already riding it, he's already in motion, and you give him a push. Okay? Your force then adds to the existing force, which then causes him to speed up. Also would be called acceleration, right? Because he accelerated when you pushed him. So unbalanced forces can act in the same direction. So if you're pushing a cabinet across the room, all right, so you're moving, one of the worst things to do in the world. I hate moving. Nobody really likes moving. If they tell you they like it, they're not being truthful, because it's no fun. The actual process of moving. The end result might be fun, but the actual process. Anyway, getting on a tangent here. So you're moving it across, you're pushing it across there with 15 newtons. Your friend, thank goodness you have friends, they're helping you move. I don't know why, because nobody likes it, but anyway, with 10 newtons of force. So what is the net force? So if I have 15 newtons pushing, and my beautiful friend here is pulling with 10, what is my net force? Simple addition here. 25. I knew you knew it. I knew it. I just didn't hear it, but I knew you knew. So what direction then is the cabinet moving? What do I look at? The arrows. So which direction is this bad boy going? To the right. Money. Okay. So unbalanced forces can act in opposite directions, i.e. tug of war. So two dogs are tugging on a rope. One dog pulls with 20 newtons and the other pulls with 25. What is the net force? So if I have Bruno here pulling with 25 and what's a good name with Bruno? Apollo over here pulling with 20, okay? Who's going to win? Bruno, right? How do I know he won? Well, because he has 25 newtons of force, so the motion's going to be going which way? To the right, right? So 25 newtons this way, 20 newtons this way. What is my net force? 25 minus 20, because they're going in opposite directions. So when they're going opposite, you subtract. When they're going the same way, you add. So here we have 25 minus 20, which is 5. Beautiful, simple arithmetic. Oh, it's that time again. Recap time. So can you give examples of balanced and unbalanced forces that were not given so far? So can you give some examples of balanced and unbalanced forces, please? Make sure those are written in your journal. You can draw those if you do not want to write. If you're artistic and you have the ability, I do not, you may do that. Also, can you explain the relationship with net force with both balanced and unbalanced? So net force, remember, if it's 0, what does that tell you about the motion of an object? When it's unbalanced, what does the net force look like? So talk about that. Final recap time. Train versus car. Which will take longer to accelerate to 60 miles per hour? Please explain the answer of why. Some bonus footage for you here. What is gravity? A lot of people think they know what gravity is, but here's the real deal on gravity. It's the force of attraction between all objects. So the amount of gravity depends on these two things. The object's masses, so how much mass they contain within them, and the distance between the two objects. So since the Earth is so large, everything on it's attracted to it, even if you're not touching, because it's large and it has a lot of mass. So example is throwing a ball. You throw a ball up, but gravity pulls it right back down. Good old gravity. Thank goodness, because I love my ball. Look at those kids. They're so happy with that orange ball. You can counteract gravity, though, by catching the ball before it hits the ground, because you provided an outside force. All right, hopefully all that's in your journal. You wrote some stuff down. You love force and motion. We're ready for that roller coaster. Have a great day.